Okay, hi everyone, welcome to this video series on Cisco ASA firewalls. Remote system management. You do not have to be physically connected to the console port of the security appliance to access the CLI. The security appliance supports three remote management protocols: Telnet, Secure Shell SSH, ASDM GUI, and GUI stands for Graphical User Interface Telnet. Cisco ASA comes with a Telnet server that enables users to manage it remotely via the CLI. The default behavior of the security appliance is to deny Telnet access from all clients unless they are explicitly permitted. You may choose to enable Telnet on all interfaces. However, the security appliance does not allow clear text Telnet communication on the outside interface unless the session is protected by an IPsec tunnel. The security appliance requires a user to establish an IPsec tunnel to the outside interface to encrypt the traffic destined to the security appliance. After the tunnel is successfully negotiated, the user can start a Telnet session to the outside interface. When a Telnet client tries to connect, the security appliance verifies the two following conditions. The client's IP address falls in the allowed address space. The interface that is receiving the request is allowed to accept requests from the client's address space. If either one of the conditions is not valid, the security appliance simply drops the request and generates a syslog message for this incident. Syslogs are discussed later in this chapter. An external authentication server such as Cisco Secure Access Control Server, ACS, can be used to authenticate the Telnet sessions. You can configure the security appliance to accept Telnet sessions on an interface by navigating to Configuration, Device Management, Management Access, ASDM, HTTPS, Telnet/SSH, and clicking Add. ASDM prompts you to select the following: interface name from which the Telnet client will be coming, IP address of the host or a network address that is allowed to connect to the selected interface, the mask of the allowed IP address or subnet address. In Figure 3.18, the management network 172.18.82.0/24 is allowed to establish Telnet sessions to the security appliance MGMT interface. So you can see here Figure 3.18, Telnet services for the management network. Example 3.30 shows the relevant configuration for this setup. If the Telnet connection is idle, the security appliance is set up to time out after 5 minutes, which is the default time. Example 3.30, configuration of Telnet access on the management interface. If a user is allowed to connect, the security appliance goes through the user authentication phase and prompts the user for login credentials. The default Telnet password to gain user access mode is Cisco. Consult the Setting Up Device Name and Passwords section earlier in this chapter to learn how to change the Telnet password. If the authentication is successful, the security appliance grants user access mode CLI to the authenticated user. You can monitor the active Telnet sessions by going to Monitoring, Properties, Device Access, ASDM/HTTPS/Telnet/SSH sessions. This displays the Telnet connecting ID along with the client's IP address. You can use the connection ID to clear out a session if you believe that it should not be established. You can do so by selecting the user and clicking the disconnect button. In figure 319, the security appliance has assigned a connection ID of 0 to a telnet client 172.18.82.77. An ASDM session is also established from the same client IP address. Example 331 shows the relevant configuration for this setup. A telnet session is built from 172.18.82.77. This connection is being disconnected by the use of the kill command. Secure shell SSH. SSH is the recommended way to connect to the security appliance for remote management because the data packets are encrypted by industry standard algorithms such as 3DES and AES. The SSH implementation on the security appliance supports both version 1 and 2. Before the SSH client and the Cisco ASA SSH server encrypt data, they go through an exchange of RSA security keys. These keys are used to ensure that an authorized user cannot look at the packet content. When a client tries to connect, the security appliance presents its public keys to the client. After receiving the keys, the client generates a random key and encrypts it using the public key sent by the security appliance. These encrypted client keys are sent to the security appliance, which decodes them using its own private keys. This completes the key exchange phase, and the security appliance starts the user authentication phase. Cisco ASA supports a number of security algorithms listed in Table 3.1. To configure SSH on the security appliance, follow these steps. Step 1. Generate the RSA keys. The SSH daemon on the security appliance uses the RSA keys to encrypt the session. You generate the public and private key pair by going to Configuration, Device Management, Certificate Management, Identity Certificates, add a new identity certificate and selecting new for key pair. Alternatively, you can use the crypto generate RSA command from the CLI as shown in the following output. For detailed information for generating RSA keys, consult Chapter 18, Public Key Infrastructure, PKI. So, Table 3.6, Security Algorithms supported by Cisco ASA Attributes, Supported Algorithm, Data Encryption, 3DES, AE and AES, Packet Integrity, MD5 and SHA, Authentication Method, RSA, Public Keys, Key Exchange, Diffie-Hellman Group 1. You can change the default module size 1024 bits to 512, 768 or 2048 bits. After the keys are generated, you can view the public keys by using the show crypto key mypub key RSA command. As you can see here, this output. Step 2. Enable SSH on an interface. You can configure the security appliance to accept SSH sessions on an interface by navigating to Configuration, Device Management, Management Access, ASDM/https/telnet/SSH and clicking Add. ASDM prompts you to select an interface name and specify the IP address mask similar to what was covered in the telnet section. As shown in the following example, the security appliance is configured to accept SSH sessions from the MGMT network 172.18.82.0/24. After a client negotiates the security parameters, the security appliance prompts the user for authentication credentials. If the authentication is successful, the user is put into user access mode. Step 3, restrict the SSH version. The security appliance can restrict a user to use either SSH version 1, SSH v1, or SSH version 2. When a connection is made by default, the security appliance accepts both versions. SSH v2 is the recommended version because of its strong authentication and encryption capabilities. However, the security appliance does not provide support for the following SSH v2 features: X11 forwarding, port forwarding, secure file transfer protocol support, SFTP, Kerberos and AFS, ticket passing, data compression. In ASDM, select the SSH version from the allowed SSH versions drop-down menu as shown in figure 3.8. To set a specific SSH version via CLI, use the SSH version command followed by the actual version of the shell. Step 4. Modify the idle timeout. Optional. Similar to the telnet timeout, you can fine-tune the idle timeout value between 1 and 60 minutes. If the organizational security policy does not allow long idle connections, the idle timeout value can be changed to a lower value, such as 3 minutes from its default value of 5 minutes. Step 5. Monitor the SSH sessions. As with telnet sessions, you can monitor the SSH session by going to Monitoring Properties, Device Access, ASDM, https://telnet/SSH sessions. This displays useful information such as the username, IP address of the client, encryption and hashing used, the current state of the connection, and the SSH version that is used. You can also use the show SSH session command from the CLI to get similar information. If you like to manually disconnect an active SSH session, click the disconnect button. CLI admins can issue the SSH disconnect command followed by the session ID number. Step 6. Enable secure copy SCP. You can use the SCP file transfer protocol to move files to the network device securely. It functions similar to FTP, but with the added advantage of data encryption. The security appliance can act as an SCP server to allow SSH v2 clients to copy files in Flash. SCP can be enabled by navigating to Configuration, Device Management, Management Access, File Access, Secure Copy, Server, and selecting Enable Secure Copy Server. If you prefer to use the CLI, use the SSH scopy enable command as follows: Chicago config #SSH scopy enable system maintenance. This section explains how to manage and install a different system image file on the Cisco ASA and ways to recover a device with no operating system. This section also discusses how to recover authentication passwords if they are lost. Software installation. Cisco ASA supports upgrading a system image file to Flash via both the Cisco ASDM and the Cisco ASA CLI. In case the security appliance does not have a bootable image, this section also discusses steps to upload the image from ROM. Image upgrade via the Cisco ASDM. ASDM can upload either an ASA or an ASDM image to the Cisco ASA Flash with the HTTP HTTPS protocol. If you click Tools, Software Update, ASDM gives you two options. Upload a file from the local computer to the local flash of Cisco ASA. Check Cisco's website for the latest version of the ASA bootable image. In most cases, you want to download a bootable image from Cisco.com to your local workstations. Many enterprises want to test an ASA image in their lab environment first to make sure the new image fits their requirements. If you choose upgrade software from local computers, select whether you want to upload an ASDM or an ASA image, and then specify the path to the image file on the local drive. For ease of use, you can also click Browse Local Files and select the file by browsing the local hard drive file structure. Specify the destination location of the Cisco ASA flash and then click Upload Image to initiate the file transfer process as shown in Figure 320. If the system flash contains more than one system image, the security Cisco ASA boots off from the first image it finds in flash. If the image you want to boot is not the first on the disk, you should set the boot order to load the desired binary image file. Navigate to Configuration, Device Administration, System Image / Configuration, Boot Image / Configuration, Add Browse Flash, and select the image from which you want. To boot, if you have selected multiple images to boot from, you can change the priority of a particular image by clicking Move Up and Move Down buttons. After a new image has been uploaded, you must reboot the appliance to load the new image. You can do so by clicking Tools, System Reload. Cisco ASDM prompts to ask whether you want to save the running configuration in the NVRAM and whether you want to reload now or schedule a time to reboot later. Image upgrade via the Cisco ASA CLI. The security appliance supports a number of file server types, including TFTP, HTTPS, and FTP. To download a system image into Flash Disk 0, the image upgrade process uses the copy command followed by the name of the file transfer type. The copy command copies the specified files from the source location or URL to the destination location flash. The destination location of the system image is the local file system. The security appliance has an internal storage disk referred to as disk 0 or flash. Additionally, an external storage device referred to as disk 0 can be used to save system images. You can also use the non-confirm option to notify the security appliance to accept the parameters without prompting the user for confirmation. This is useful if customized scripts are used to upload system images. Example 332 illustrates how to configure the security appliance to download an image file called ASA821K8.bin from a TFTP server located at 192.168.10.250. The security appliance initiates the download process and stores the image file as ASA821K8.bin. Example 333 illustrates how to configure the security appliance to download an image file called ASA821K8.bin from an FTP server located at 192.168.10.251. The username is Cisco and the password is Cisco123. You can verify the download image file was successfully saved in Flash by typing the dir command as demonstrated in example 3.4. As mentioned earlier, The security appliance allows multiple system image files to reside in flash. If rebooted, the security appliance loads the first available system image. You can modify this default behavior by using the boot system command to ensure that the newly uploaded image file is used for boot up. This is shown in example 335, where the security appliance is set up to boot from ASA A21K8.bin. The last step in verifying the security appliance is running the desired version of code is to issue the show version command as shown in figure 338. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.